Good day guys. We go with the next algorithm, alpha beta pruning. We take the same example what we have looked into minimax algorithm. Here we look for the alpha beta pruning. So before we kickstart the algorithm, how it works, first understood what is the term pruning means. So because this term pruning, you would be having a more knowledge, or you can say how the pruning will be working in the machine learning while you compute the data sets, right? The pruning is nothing but trimming, right? It's very simple. We just cut short certain things or certain steps if it is not required. So we can say the computation time could be reduced. If you are cutting a few steps, that will result in reducing the computation or execution time. So in the same way, the example what we seen for the minimax algorithm, at some sort of time, it doesn't create any sense when we go for the dick of the right hand side. Say for instance, if you are going for the right hand side dick to search for the element, then comparing with the player, whether it's max or minimum, then treating the same value to be retained over there. In that case, right, the right hand side digging searching is doesn't create any sense, but still we does it, and that actually result in a the computational time to be a bit higher. So that's what going to be solved by this alpha beta pruning. So again the same example. So how we used to go, we go with the DFS fashion. So the 10 over here. So now the 10 we'll be having 10 comma 9. We'll be comparing with the which is minimum. But before that, by this step, that is while we done this 10, we'll be checking with the parent, right? So while we checking, we have to look for one particular rule. We can say it's a rule that is alpha greater than or equal to beta. In that case, we'll be applying a pruning. So, hope you remember, the pruning is nothing but trimming, right? We'll be just cut shorting it in order to reduce the computational time. So, the same way, so we have dipped the 10, we are having the parent as 10, the parent of 10 doesn't have any value, so no other go, we cannot check the rule alpha greater than or equal to beta. And remember, right, I can make it so easy for you, right, to recall. So we already know this is max and max is alpha, this is min, min is beta, and again this is min and this is alpha. Just remember this, alright. So now 10 doesn't have a parent, so obviously we have to go for the digging of the right search element, that is 9, and 10 comma 9 the same how we done in the minimax. We'll be checking, we are in the maximum level, right? It's max min, right? Sorry, so this should be max, this should be max, I'm sorry, right? So now 10 doesn't have the parent and we are at the maximum level. So 10 comma 9, so 10 is the maximum, so 10 is retained, so this is correct. Now we'll be moving this 10 parent with the same value 10, and we are checking the alpha greater than or beta value. So we are checking the parent of the 10, it doesn't have any value over here. So the 10, no other go, we have to go for the search element of the right hand side. Now again the 14 will be pushed over here. So now before going for the right hand side, now we will be doing the check with the parent. So parent, we do have the parent is a 10 and this 10 is at the level of a min, that is beta. So we can say beta is equal to 10 and this 14 is level of max and max is nothing but alpha. So alpha is 14. So we do know the protocol. So what is that protocol? Alpha greater than or equivalent to beta. Then only the pruning will be applied. So what is alpha value? It's 14. What is beta value? It's 10. So check the constraint. Of course 14 is greater than or equal to 10. So 14 is greater than. So what we can do, we can simply cut short the right hand side dick, so we can illustrate with this double strike over there. So it actually implies that no need for the right hand side search to the leaf node element. So now the usual process, we do know the 14 is over here and now we are having 10 comma 14 over here. So this is at the level min, so minimum value 10 is retained here. Alright, so now what is the parent of 10? We don't have any parent, so as of now we can have the parent is 10. So as it is a root node, parent node, we don't have the comparison to perform. So we'll be going for the right hand side as what we used to do in the minimax. So go over straight away over here. We'll be having 5. Then right hand side at 5 doesn't have a parent, so right hand side has to be dig. So 5 comma 4, we are at the maximum level. So which is maximum? 5 is maximum, 5 is retained, and now 5 will be pushed to its own parent. Now we are going to check 5 have the parent or not. Of course it does have the parent. So what is the parent? Parent is the max node, so it's an alpha. Alpha is 10 and 5 is a beta, it's a min node. So 5. So what is the rule for us? It's alpha greater than or equivalent to beta. Of course alpha is greater, that is 10. So what happened? We'll be performing a pruning operation. So no need for the further dig over here. We stop here and now 10 comma 5 will be compared, and we do know we are at the level max. So max will be retained. So 10 will be freeze. As earlier how we solved the minimax algorithm, now we understood that this 10 is a guaranteed score for the max player and it has been fixed, and this is how the path will be to reach the guaranteed score. But only discrimination between the minimax and alpha beta pruning, we are trying to cut short few steps in order to reduce the computational time so that the machine can perform the same guaranteed score but with the less computation time. So it's very simple, right? It's easy.